Hello, welcome to Mo-Sys LiveLab, our webinar series. Today we're going to talk about Mo-Sys VP Pro, our plugin for Unreal. It's a follow-up webinar to a webinar we had a couple of weeks ago where we talked about StarTracker Studio, our all-in-one cost-effective solution for virtual studios. Before we dive into the webinar, just a bit of housekeeping up top. The webinar will be roughly 40 minutes long, and then we have 20 minutes for Q&A, which brings me to the next point, the Q&A. It's you can use the Q&A feature at the bottom of your screen. There's a button, you can just click on it and type in your question. For this webinar, we try to keep it very interactive. So if you have a question and you want to have them answered immediately, just mark them with 3 asterisks, or you can type in now all in capitals, and then I will jump in and ask our speakers immediately and not wait till the end. The webinar will be recorded. There will be a recording made available on our website later, probably beginning of next week, and you can find it in our website on our webinars page, where we have a bunch of prior webinars where we talk about the UE150 integration with StarTracker, or the U50, a remoted robotics for broadcast that carries heavy box lenses, for example, and many more. So feel free just to have a look and watch some of those webinars. The webinar today, we will talk about our software plugin for Unreal. Let me just share the screen. So we called the webinar Deep Dive into the Mo-Sys VP Pro Plugin Virtual Production Suite for Unreal Engine powered by StarTracker camera tracking. It's a long title, but all will be explained. So we have 2 speakers lined up. We have Mike Reeve, our commercial director, and we have James Uren, who will be the one who is actually doing a run through the software. At the end, there will be a Q&A, so I will be back for that. But as I said, if you have any questions and you want me to ask them during the presentation, feel free to ask. Okay, so without further ado, I'm going to hand over to Mike. Hello, Mike.
Hey, Marcus, how are you?
Good.
Good, thanks a lot. And welcome to everybody. Good morning, good afternoon, wherever you are. Thanks for joining us and taking the time to learn a bit more about our VP Pro plugin. Virtual production is a word that has become an umbrella term for all things involving compositing live, real-time 3D graphics on either virtual or real backgrounds, and it covers the broad spectrum of virtual studios, augmented reality, mixed reality, on-set previs, on-set finishing, and we're going to talk about VP Pro in terms of the markets that is targeted at. But generally speaking, when we're doing virtual studios, augmented reality, and mixed reality for broadcast, Mo-Sys supplies the tracking, our StarTracker system, and we work with vendors like VizRT, like Zero Density, Brainstorm, the Future Group for Pixtope, where basically we do the tracking and they do the virtual studio software, and it works really, really well. And we work with those vendors because their software integrates into playout systems and automation systems and rundown systems for news. And that's not something that we get into. So we work very happily with those vendors. Now, for other markets where we just need to provide the virtual studio in an Unreal environment, and for that I'm talking about the enterprise and corporate world, or for film VFX production, we use VP Pro in conjunction with StarTracker. And VP Pro is in 2 forms at the moment. We have one form which we use in our StarTracker Studio, which is this all-in-one, all-encompassed, pre-configured, pre-wired, pre-loaded system and we have Star Tracker Studio in there, and that's a special version of VP Pro, which is a license that covers between 1 and 8 or 9 and 16 different cameras. And for that market, it works particularly well, where we're selling into an environment where people don't have the experience to build virtual studios, or they don't want to, and we provide an all-in-one solution. And VP Pro in that environment works particularly well for them. Now, for the film effects marketplace, we have VP Pro as a separate license, and that takes us into doing virtual production or VFX production using either green or blue screen or with LED volumes. Now, we're not unique in having a plugin for Unreal. Most tracking vendors have their own version of an Unreal plugin, and those generally do the same types of things. They basically allow the camera lens and camera positional data to be taken into the Unreal environment. And we also, or they will also have the frame synchronization, because of course games engines, the Unreal Engine would run as fast as it could if it wanted to, and we need to lock it to 25, 30, 50, 60 frames per second. So it provides frame synchronization as well. And also it does the compositing. It puts the Unreal elements on a live background, a real background, or puts a background made of Unreal with real talent. So most of those plugins do the same kind of thing. But what we're going to talk about now is VP Pro, which is our plugin, but there's an awful lot more than just those basic requirements. James Ewan is going to speak shortly, and his team have been developing for some time now a large and comprehensive suite of tools that work in conjunction with the Unreal Engine, but specifically for film VFX production and for working in LED volumes in addition to green and blue screen environments. And I'm going to hand over now to James. James is our technical director. He's going to give you we called it a deep dive earlier on this morning. It's probably a medium dive, and give you an idea of what this product is all about. And then we'll take some Q&A at the end. So James, if you're there, I'm going to hand over to you.
Yes, I'm here. Thanks, Mike. And I'm just going to share my screen. I've got a few slides, and then we'll get right into the Unreal Engine. Thanks everybody for joining. As Mike said, when we ran this earlier today, I didn't get as deep as I'd hoped to. So it's kind of a medium shallow dive. But there's a lot of features to cover. I'll do my best to get through everything. Mo-Sys, primarily known in film and broadcast for camera tracking and robotics. On the left there, that's our Star Tracker system. It's a combination of that processor unit and the sensor. The sensor looks up to the ceiling, or it can be facing the floor as well, where we have a lot of these little stickers, which we call stars. And that's how we track the camera position in our system very precisely and robustly. And we have a lot of robotic systems. I'm sure you've had a look at our website, and you'll be have a browse around those. And they've been used on a big range of everything from high-end Hollywood production to wildlife, to all sorts of things. And around about 3 to 4 years ago, when we were developing our lens calibration system, we started to work with the Unreal Engine. And so we've been actually working with the Unreal Engine for quite a while now. And we started to build tools that we needed for our lens calibration process. And we realized we sort of had built quite a lot of things that would help in a virtual production environment. So we decided we'd wrap it all up in a plugin and make it available. This is not a very good definition of virtual production, but it's my lame attempt to do it in 10 words or less. The key thing about virtual production is that it's real time, and that's why a game engine is such a good choice for creating the graphical elements. Because in a game environment, you are rendering everything in a frame, and it needs to, we need to get, well, what virtual production is really is an example of the convergence that's happening between the video game world and film and broadcast. So really it's about creating content that is, a combination of live action and graphics, but actually it can cover CG only applications as well, including planning your production in pre-production for creating virtual storyboards, and Epic have some really cool tools for that. You should check out the VR Scout. In the pre-production phase, you can put a VR headset and move around your scene and drop camera positions and stuff. But where we sort of come in is where VP Pro comes in is in terms of integrating live action with that. So, and those are, Mike already talked about some of those things on that slide there. But for CG only applications, we've actually released a free version of the plugin that doesn't involve live action at all, doesn't have any compositing stuff or sync, but it does allow you to use our hardware right now in a virtual production CG only context. So this CG only, you can still obviously create a production without having any live action. And I have a little example of something that we did a little while ago with a great friend of mine, Asa Bailey, and his team on Set Facilities. And this was done in our studio here where I am now. We had my friend Alex in a motion capture suit from Xsense, a very cool inertial suit. And you see he's got one of our headset adaptions on, which has the Star Tracker mounted on the top of the, I think that's, is that a Windows headset? I'm not sure. And you'll see in a moment, Asa orbiting the motion capture performer with one of our handheld VCams, which also has a Star Tracker mounted on it. And then in just a moment, you'll see another friend of mine is a camera operator. Here we go, using our hand wheels, but to drive a virtual camera in the scene. So that's an example of a CG only application, CG only virtual production. And this could be done entirely with our free plugin and our hardware. And of course, the nice thing about Star Tracker for this application is because it's absolute, you can keep adding Star Trackers to things, but it's all in the same 3D space. So it's very easy to use them. We actually realized halfway through this production that we had a free camera that we hadn't thought about, which was the headset actually became a POV camera that could be cut into the edit as well. You can see it quite clearly there, the viewfinder. So with our free plugin, what we've done is enable you to get tracking data into the engine over the live link system, and you can then integrate that with motion capture, facial capture, and of course you can record all of that and render out the resulting camera movements, because we're now also interested in capturing the performance of the camera operator in those environments. But if you want to integrate live action, things get a lot more tricky. So I always say there's sort of three things that you need to have a good integration of live and CG content. And those are, you need to have high quality tracking with the lens distortion built in. So we need to be able to model the lens, calibrate it, and then live capture that lens information and make sure the CG matches the natural distortions in the lens. We need to be able to composite in real time. So we need to compositing is overlaying the live and the virtual, or the other way around. Or sometimes slotting the live in between CG objects, for example. And all of this has to be done with a very high level of synchronization. So when you move the camera, the CG appears to be completely locked to the live. So VP Pro is a plugin that basically enables you to do those things, and it turns the Unreal Engine's editor into a virtual production suite. And that means it can be used for all of those things. We don't, the previous side, which is CG only, you don't need VP Pro for that, but for any integration of live action, that's where you're gonna need the VP Pro system. We divide our plugin into 4 different compositing modes. So, and I'll quickly describe those, and then we're going to jump into the demo and see AR mode. So AR mode is where the graphics are entirely always on top of the live action. So you don't need any green screen in this environment. It's entirely just one overlaid on top of the other. I have a little video of that, and then we'll jump into the demo. This was done last year, at the end of last year in Mexico. This is a real studio, as you can see, and Arturo from Keith Frame there, he's integrated our tracking with Dynamics YZ face tracking, motion capture, and is able to composite a CG character live into this sports studio. And you can see it handles glow and the shadows and all that compositing is working really nicely. And of course the camera is moving, which really helps to sell that he is in that world. Okay, let's jump over to our live demo now. So I'm going to hop into Unreal. So this is our plugin. I'm going to kind of go around it in a second, but let's just see it in action first. I've got Olix with me in the studio. Say hi, Olix.
Hi, Olix.
Thank you, Olix. And he's on the camera there. So let's just pan over. There we go. So you can see we've got these guys helping us out clean our studio here. And this is an entirely AR system. So although we're in a green screen area here, that's just because our studio is green. We don't need to be. In fact, Olix, do you want to just pan around to the left, and we'll show that you don't need a green screen to be able to do this, because it's a little confusing that we're in a green area. So there we go. There's another one of the Epic mannequins doing the ironing. Perhaps, yeah, I was going to say, if you just zoom in a little bit, you'll see how synchronized the lens and tracking is with the virtual. And that's really what, when you go from a sort of, you know, a prosumer grade tracking to a professional grade tracking, that's the sort of the step that you have to take. And just do some sort of crash pans and crash zooms around for me, just so we can see. So you can see how locked that is, and just punch in right onto the, yeah, there we go. So you can see how synchronized that is. And that, for that you need the sort of Star Tracker grade of tracking. And then, of course, you need the Unreal end, or the graphics engine end, that can cope with the lens distortion that's coming, this distortion model that's coming from the camera live. Okay, so let's have a little look around the plugin itself. Basically, anything you can see on the Unreal Engine editor with a little M here is part of our plugin. It's been added by our plugin. So we don't actually mess with the editor itself at all. We just simply drop our things into the editor. So you can see here, would you mind just moving the camera around to something a bit wider so we can see what's going on? Actually, just keep it on the ironing board, but just zoom out for me so we can see. There we go. So this is the vanilla Unreal editor that you download for free from Epic. And then all you have to do to install our plugin is drop our plugin into the plugins folder, and then you get all of this additional functionality. And you can see it's all updating live in the editor, which is something that we've just sort of made work in the last couple of versions of Unreal. But because we're a plugin, we're actually able to release our software, our plugin, on the day of release of the engine. So we really pride ourselves on that. So as soon as 4.25 came out on that day, we were shipping our plugin out to our customers for 4.25. So instant access to those features. And we keep our release cycle in sync with Epic's release cycle. And because it's a kind of subscription model to the plugin, we can keep building and adding features, and every release it gets better and better, and everybody benefits from that. So you can see I have our Star Tracker window here. I've got Live Link, which is where the data's coming in. I've got this handy status window, which tells me if something's wrong, and it doesn't just tell me that, it actually tells me what to do to fix it. This was something we added in the 4.24 release, and it's been really popular thanks to Epic providing the ability to create these little widget panels. Our previous versions of the plugin didn't actually have any UI at all. We've been able to add that in the last two release versions, which is about 6 months or so. And we have a whole load of prefabricated components. You can see there's a camera here that you can just drop into your scene for whatever mode, compositing mode you're using. So here's our AR camera here. And if I have a look at the contents of that AR camera, you'll see it's doing quite a lot of stuff. It's doing handling the lens distortion, the compositing, the tracking, and synchronization. All of that's done on the camera. So you just drag it into your scene that you've already created in Unreal, and then you, and it will do everything else for you. If the star tracker is sending lens data, then it will just start doing the lens distortion. You don't even have to think about it. It's pretty cool. So that's the an overview of AR mode. Oh, there's one more thing to say, which is that in AR you don't get shadows, of course, because there's not normally any floor. If we had a CG floor like this in the shot, you would see it, not the real floor. So we've actually got a special AR shadow system. This is our AR shadow system here that you can drop in to the scene. Again, it's a nice drag and drop prefabricated component that gives you the AR shadows that help, you know, locate the CG object in the scene. Okay, I'm going to drop over back to the slides for a minute, and then we'll talk about some of the other workflows. And in the meantime, I'm going to launch the project in the other settings. So I'm just in another mode. It's a little bit more of a heavy project than this, so it takes a few minutes to open up. So let's get that opening, and then we'll hop back to the slides. So the other modes that that we can operate in involve removing the green screen using chroma key, and we can either use our internal keyer, which is based on the keyer that Andy Blondin at Epic wrote. We've added our garbage matte system to it, but basically it's the same system. And it's a perfectly good keyer for previs, but it's not really a production key. So for full-blown production keyer, we recommend using an external keyer like an Ultimatte or similar. And the demo I'm going to hop over to now is actually going to use what we call pre-keyer mode. So this here is pre-keyer mode, where the engine sits before the keyer in the chain. That means the keyer is doing the compositing. So the engine is actually just going to be generating CG out of it. There's two channels here, one for the CG scene and one for the garbage mats, because we also need to potentially mat off areas of the studio where we don't have green screen. All of our keying modes support 360 garbage mats, 3D garbage mats, so you can spin the camera around and you won't see the back of your studio. You'll just see CG. I should say that I know a lot of people are excited about the LED wall stuff, and I am going to talk about it. We don't have we have some tools, and I'm going to get there. And I meant to mention it at the beginning, but we had a lot of questions about LED wall stuff in this morning's webinar. So if you have questions about LED wall, I am definitely going to get there. So please hang on and be patient with me. Let's see if Unreal has opened. It has. Excellent. So if I just hop into play here, and then we're going to need to, because the engine is only producing CG now, we don't have any subject here. So I'm going to ask Olex to show us the stream, if that's all right. Are you in position to do that? That's it. Brilliant. Someone's done it. Thank you. Okay. So what you're seeing now is a pre-keyer composite. So this is the keyer doing the compositing. You can see it's a very good quality key. I think I can show you, there we go. So that's what we're seeing. That's what's coming from the engine. That is the matte, as it's called, that it's creating. And that's the final composite. And so those, that's the Ultimatte creating that. It's doing a really good job of keying that. And of course, we can still move around because the engine is generating CG. And we're of course still handling the lens distortion because the CG has been distorted to match the real lens. Okay, I'm going to go back to sharing my screen now. We can leave that up.
James, there's a question from Dear. Does the AR shadow system support reflections as well?
Actually, you're not the first person to ask me that. It's on my list. There's no reason it wouldn't. We haven't done it yet, but it certainly will do very soon. And if the way we often work is because we have quite a long list of feature requests. If people have a production that requires that, then we build the feature. It goes right to the top of the priority list, and then everyone benefits. So that is on my list. It's not done yet, but if you had a project, do please get in touch and that required that feature, and we'll see what we can do. And we often are able to turn around things like that quite quickly, especially in that case where we've done it with shadows already. So, any other questions, Marcus, for the moment, or shall I crack on?
Yeah, you can crack on for now.
Okay. Yeah, you can see here I've got the kind of just now the CG output from here, but I can also use the system to record. So I'm going to load the live layout now. The live layout is for recording. You can see there we have a few different preset layouts, and now we have a different set of panels to help with recording the data. We use Epic's take recorder and sequencer to record the tracking data. And then we have our own take log system that kind of stamps time code onto that and also creates metadata. So if I just have to reset take recorder here, that loads up the take recorder with all the correct properties and everything. And then I can go ahead and do a recording of that. If I'd wired it up in the blueprint, but I clearly didn't. So, well, I guess that means you're going to see how to set it up in the blueprint. So I'm just going to, it's very simple to set up. You just add spacebar and then start stop Mo-Sys recorder. There we go. So that's an example of a simple blueprint that you would just create for your level. And let's close that. And now when I hit spacebar, it should roll record on the recorder. There we go. And it's now recording the tracking data. And when I hit stop, it goes ahead and copies that and stamps it with the time code. You can see that. And that's going to give me a take in here. And that take, I can export that and I'll get a long list of those at the end of the shooting day. This is for a workflow where you're using Unreal for your on-set pre-visualization. So you're removing the green screen live on set, but you're intending to use another 3D package to create your visual effects in a traditional VFX pipeline. Then it's really helpful to have the camera movement from the day, and that for a lot of shots you'll be able to use that tracking data rather than rebuild the camera in your compositing software. I'll just show you what you get out of that. So if I do an export from there, I get, for every single take, I get an FBX file, which you can hand over to post-production. And you get one of these handy metadata files that tells you about some information about the take. So what scene and level you were using, what lens was loaded. And if you have one of our supported cameras attached, then you can also get direct camera information here as well. So that's part of the bundle that you hand over to visual effects at the end of the shooting day. There is another workflow where if you're wanting to use Unreal Engine for what they call final pixel, which is where you're actually going to render the background out again, you can take that camera sequence that we made here, so this guy, and you can re-render that out. There you can see all the information, the tracking data and all that stuff, the lens distortion. You can then play that back and render that out. And you can also turn up all the dials now. You can turn up your ray tracing and all that stuff because you're after the fact. You don't need to be real time anymore. And you can then take the plate that you recorded in camera, so the green plate, and just do a 2D composite over the Unreal rendered plate. So there's sort of a 3D compositing and a 2D compositing workflow that that's supported by this. Okay. Just hop back to my slides. So I've got a little video to show you just about the lens distortion. This is quite an interesting just description of how important the lens distortion is, because it really is the difference between it sort of working and not working in terms of the, fooling your brain that this is really, this CG object is really in the real scene, or vice versa. So let's just load this video quickly. So this is a test that we shot, and you can see there's a few options here with and without lens distortion. And this is a very hard model here because we're a checkerboard on the floor, so we're trying to really push the system to the absolute limit here. And you can see without lens distortion, the chair just slides around on the floor as you move. Particularly, you can see it as you tilt there. And that is, oh, it's rolled on to the next one, apologies. And that is really what our lens distortion system does. And how it works is we calibrate the lens first. So we do that in our lab, and the lens distortion is then stored in a lens file. So the model of the lens across all of its zoom, if it has zoom and focus ranges, is stored in the lens file on the star tracker. And then with every tracking frame, so every position frame of where the camera is, it's also sending the lens mathematical model to the engine. And then the engine just has to adjust the CG to match the distortion of that natural lens. So we're familiar with the idea of compositing with green screen. It's been long used in weather and all that kind of stuff. What we've just shown you there with the compositing using the keyer was pre-keyer mode. And this is it's very efficient, it's very light way of on the compute. But it does have the problem that the engine doesn't know anything about the live action video, which means you can't have reflections, as one of our questions said earlier. In this mode, you can't have reflections in the engine because the engine doesn't know anything about the video. So to enable that, we have what we call post-keyer mode, which is all still using an external keyer, but now the keyer is before the engine, and the fill and key signals that I showed you from on the mat there, so the mat and the corrected front plate are then composited in the engine, and now the engine can have reflections and shadows. Of course, this is more computationally heavy.
Okay, James.
So yeah, that's.
Sorry, there's a question from Harry. Does the system work wireless, the tracking system? Is there an option to use it wireless?
Yeah, absolutely. Yeah, we have a really, well, for a long time we've supported a Wi-Fi solution with tracking, but it really is just, Wi-Fi is just notoriously unstable, and it's really, certainly if you're planning on recording the data or you're doing live production and you care about the tracking being really consistent, then we strongly recommend not using Wi-Fi basically to transmit critical data. So we've developed a new system, wireless system, that actually embeds the tracking data into the video signal. And then you can transmit that video signal over a teradec, for example, over a wireless RF link. And then if you are using another graphics engine, then we have a decoder box that you can that turns it back into network data. But if you're using the Unreal Engine, we can actually decode it directly in the Unreal Engine, so you don't even need to have the network side at all. It just gets it from the video and then starts moving the virtual camera around. If there are any other questions, Marcus, then I'll take them, or I can just talk about LED wall for a little bit too. I've left myself enough time, I think, this time to talk about LED wall. So shall I jump to that, or do you have any more questions at the moment?
I think there's another question from Harry about the goggles he saw in the video. The
VR headset, yeah.
So maybe you can explain. just very briefly?
Sure, yeah. So with the VR headset, we don't manufacture our own VR headset. What we do is we work with all the major headsets, so Rift, Vive, HP, and we mount a star tracker to it, and then we fuse the data from the headset with the tracking data from the star tracker and feed that into the engine. This is kind of trying to get the best of both worlds in terms of tracking, because the headsets are very good at fast movements and low latency gyro and accelerometers, and we're very good at absolute tracking. So that means what it sort of enables is for large spaces, so huge spaces for VR experiences, and also multi-user experiences too. So it's quite a cool system. We can certainly, if you've got a specific project, again, do please let us know. We'll try and support you with it. I should say we also obviously we're primarily talking about Unreal here today, but for VR we do also support Unity as well.
Okay, thank you, James.
Okay.
Yeah, I think it's time now to talk about LED walls. Okay,
great. So for those of you who, that's the reason you're here today. Thank you for your patience. Are you, Marcus, are you able to wander just round the corner and into, is our LED wall up and running at the moment?
It is up and running. So,
okay, great. So Marcus is going to take a wander around. Alex, perhaps you could pin Marcus on the display and he'll show you. So we've been working with LED walls for quite a while now, and we recently have borrowed one from CT London, and we've been doing a bunch of R&D and developing tools specifically for the end display workflow in our plugin. We just, in fact, our sort of main engineer who's been working on this has actually gone to pick up all of our stuff from Shepperton right now, one of the big studios in the UK, where they've been doing a test with a large post-production facility. And this is, so here you can see the star tracker on an Alexa with some kind of lovely prime on it. Oh, it's an Arri Ultra Prime. Okay, great. And we've been doing a bunch of tests in this environment, and you can see we have a 3 walled volume. It's not big, but it's big enough for us to do our kind of R&D. We have already done a lot of work on sort of making it easier to configure. I should say, just for a bit of context, the original way that this worked in Unreal was using a system called VRPN, Virtual Reality Peripheral Network, and we we supported that. We've supported that for quite a long time now, and so some of the demos that you've seen online of this stuff, Stargate Studios with the motorbike and the train, that was all using our tracking system through VRPN, and also the I don't know if you've seen the Ghostbusters car at CES. That was also using Star Tracker. Star Tracker is a really good tracking system for this environment, and we. Yeah, and so we're kind of, doing a lot of work on this because there's a lot of interest at the moment, as I'm sure many of you are aware. Is it actually live at the moment? Okay, yeah, it is. So, yeah, for those of you not familiar with the technology, the idea is that as Alex moves the camera around the space, the projection of that camera's frustum on the LED wall changes, and that gives the illusion of 3D. So it only works from exactly the camera's perspective, right? It doesn't really work from where we are here. It will work a little bit probably. You can see as he's trucking over to the right there, you can see the parallax in the background changing. So, and the idea here is, of course, to capture in-camera visual effects. This means that we can place a subject, perhaps, I don't know if there's somebody who can stand in front of it and just, so I can demonstrate the lighting side of it. Perhaps, Alex, just leave the camera still for a second and just step in for me, if you would. Thank you. So with we're not really seeing it on this webcam, unfortunately. I'm sure we would see it on the Alexa, but if he was stood in front of a green screen right now, then he would be getting a lot of green spill on his shoulders and on his arms. But with an LED wall, the spill is actually the correct spill that's coming from the scene, which is the reason why people like it. It's not really showing up on this webcam view, but that's really, you know, the nice thing about it. It saves a lot of that effort in compositing. It also obviously locks you in to what we're seeing here, because if you're capturing it, then you don't have the opportunity to change it later. And there are also a bunch of other artifacts that you can get from shooting in front of an LED wall. But what we've done, first of all, is moved on from this VRPN approach to the very latest approach that Epic recommend, which is using NDisplay more in the editor, which fits really well with our plugin architecture as well. And we're basically now offering as a service, you know, to come and help you with the NDisplay configuration, because still there's lots of bits and pieces that are difficult to join up. As we did with virtual production with the VFX pipeline, we are listening very much to productions and building features that they want, and we're trying to make it easier and glue it all together. But we're really just at the start of that with LED Wall. But we've made good progress. As I said, we've just been on a set this week at Shepperton. Lots of people doing tests at the moment. We did another test about 2-3 weeks ago. There's, you know, we've had really good feedback on the tracking, the type of tracking for this approach. In our plugin, we now also have an NDisplay camera and an NDisplay layout, which basically help do a lot of the configuration for you. Not everything, because we're not quite there yet, but we have also documented all of this, and we're in a position now to provide that service to productions in terms of kind of gluing it all together. Thanks, guys. Should we hop back to Q&A now? Marcus, if you head on back, I'm sure there are some questions. I can see one here actually from which I'll answer. Is the drop frame for live feed on pre-keyer mode? So I'm guessing you're talking about drop frame rates. So 5994 or 299796, you know the one I mean. Yes, absolutely, we support all the drop frame rates, and Star Tracker does too. Star Tracker will run either free run, or it will run at the frequency that you genlock it. So you can genlock it with an NTSC sync, and it will run at 5994. Marcus is back, so he can take over on the question sharing now.
There's a question from Kati Kayan. Kindly explain on genlock for Cam and Unreal Sequencer. How do you genlock the systems?
Sure. Yeah. So just for those who are not familiar with genlock, because it is a very broadcasty thing, and if you're from the film side, you may not be familiar with it. Genlock is this system that's been used for a long time, actually, to synchronize multi-cameras environments. And we use it, it's a signal that goes along a video cable, and we use it to synchronize Star Tracker with the camera. This is really critical, because it means that you know that the tracking and the video are taking frames at exactly the same instant. So we actually genlock at the camera end, and then we know that the tracking is lined up with the video at the point of capture. And then in the engine, all we need to do is assign the correct frame to the correct frame, and we use timecode for that. So there's kind of intra-frame sync, which is your genlock, and inter-frame sync, which is your timecode. You don't need timecode, but it's a nice way in the engine of making sure that you have the correct frame and setting your delays.
James, it's Mike here. Can I ask you a question that came up this morning afterwards, because it's quite relevant? So there's a lot of interest in LED wall, virtual production. Everybody's talking about, we're inundated with calls about it. But does this mean the end of blue screen, green screen? Do you think it's going to take over and we can throw away our painter studios and go out and buy LED walls? What's the future hold?
Oh, well, that's a very good question, Mike. And I think, yeah, I think the future basically, well, my personal view, and I, you know, is I think the future is a kind of shared approach. it's going to be part of the future of virtual production, absolutely, and certainly the dynamic lighting stuff is really, really amazing. And but I think, and it is also, you know, I've been on these sets. It is so cool to see it all in camera and to record it there on the day, and you see the, you know, the responses that it gets from the cast and the craft practitioners is amazing. But it is really expensive, and it also does bake it in. There are also, as I mentioned, quite a few artifacts. So it's definitely not a panacea. It's not going to solve it's not going to solve the problems of COVID and production in these weird times and all that stuff. But I think it's going to just be another tool in the toolbox. And I think that one thing that we're doing on these tests is what we call a dual pipeline, where we actually people sometimes think, you know what, this just isn't looking good enough. I'm not happy with how it looks in camera. Let's just flip the LED wall over to green screen. It then, of course, becomes a very, very expensive green screen. But what we've done in our tools is allow you to shrink the size of that green. So it's only the bit you need to be green. We've also have this pipeline where you can combine it with previs, which means you can, Video Village can still not be looking at a green plate. They can look in a traditional VFX previs plate. So I think the future is sort of a combination probably, and that's the direction we're heading technically.
Yeah, that makes total sense. Yeah, I think it's a dual use world, isn't it? And you'll pick your VFX shot and decide whether it's going to go one route or the other, and it will take you down those routes, and that's fine. Yeah, great. Thanks for that.
No worries.
Thank you. Question for Mike. What's the difference between VP Pro plugin and the Studio plugin you talked about earlier?
Yeah, that's a good point. So VP Pro is a single license, so it goes on a single camera chain, and that one's used for doing the VFX workflow. In the Star Tracker Studio, we have a different scenario. We have a different challenge there. So anybody who's seen the picture of that rack will see that it's got one keyer and two PCs, yet it will support up to 16 different camera chains. How is that done? Well, it's done because we switch the full composite from each camera into one of those PCs via the keyer. And in order to do that, all the cameras have to have the ability to be connected into the Unreal Engine for their background. So it's a license that will serve either 1 to 8 or 9 to 16 different camera chains. But it's essentially the same software. It's just that we have to do something special on that product to get 8 cameras switching if we need them in a live environment.
Okay, we have a question that is addressing more the traditional way to do virtual production from O'Dare. When using an external keyer, for instance, Ultimate, if you change projects in Unreal, will you need to adjust the camera delay? In other words, is the delay consistent regardless the complexity of the graphics?
It's consistent, yeah, because we're always, it doesn't matter how heavy the scene is, it will always still need to render within one real-time frame. So the delay doesn't change. There is a delay in the system, as you rightly point out. We have to process the tracking, render the CG, and then get it out on an SDI. But that delay doesn't change. So once you've set it, in the case of pre-keyer mode that we saw earlier with the our model in the scene, that we were running a 4-frame delay on the video there, and that was sufficient to compensate for the delay in the CG side. So with LED Wall, Mandalorian was running at 9 frames delay. Our system, we managed to get it down a bit. We've got it down to 7 frames, but it is important to be conscious of the delay that's inherent in the LED. In a VFX environment or a live production environment, having a delay is not as a big a problem because once it is, even if it is delayed, it's still all synchronized together. But of course, in an LED environment, if I pan the camera quickly, then the background will be delayed behind. So you're restricted with LED to moving quite, slow and nice camera moves for the effect to be maintained.
James, another question that I had yesterday that came up is to do with LED walls and moire patterning. And the question was, if you have a higher resolution sensor in your camera, does that help or hinder, or does it not make any difference in the patterning you get?
Well, it will certainly be different, but it won't make a difference in terms of how much moire you will get. It will change where you get the moire effect appearing. For those who are not sure what it is, it's basically an artifact where presenters on TV used to get it if they wore stripy shirt. It's basically if you have two grids overlapping, you get this weird spirally kind of effect, and that's called moire. And you see it very clearly in an LED wall when you're at certain positions and certain angles. The sort of absolute base way of approaching the problem is to defocus the LED wall. So have a shallow depth of field on your subject. That means the LED wall is soft. Then there is no grid to interfere with the grid that's in the camera's sensor, because those are the two grids that are interfering: the sensor and the LED wall's pitch. So this is something we're absolutely in the middle of investigating right now, and we're looking at some tools to aid and mitigate that effect.
Great, thanks.
Okay, there's a question from Juan regarding the hardware. What would be the minimum required for a GTX card? Would 208 Ti work, or do you need Quattro in a Chroma setup? So
our recommended minimum spec for ray tracing is a 2080 Ti. So it's not a hugely expensive card. We run all of our development and all of our testing on that, or sometimes even lower, 1080 for non-ray tracing. So but once you get into that part of it, it's really, you'll get more grunt out of Unreal. You'll get more power from Unreal if you throw more GPU at it, but obviously there's a cost attached to that. So we say there's sort of a minimum level to get a really high quality scene is 2080 Ti. That's what you saw there, I think, is 2080 Ti. And that's actually with no ray tracing on as well, what we were showing that scene there. But I suppose it's worth saying that we're not really, although we're obviously very familiar with Unreal and we work with it every day, we aren't really the content people. We're very much about providing the technology and the tools and the hardware as well to make it all work. So if you are looking to go down the route of using Unreal for your virtual production, then we would really recommend, either bringing someone to your team that has those 3D artistic skills or has worked with Unreal, or genning yourself up. There is a huge amount of Epic have a brilliant education and learning resource. Do check it out. They have loads of tutorials, videos, how to get up to speed in the content creation side, and then hopefully once you've created your set or your studio, whatever it is inside Unreal, then bolting on our plugin and the virtual production bit is the easy bit. You just drag and drop in the camera and away you go.
Okay, excellent. Back to our hot topic, LED walls. Do you recommend a good approach for mounting the tracking dots in case of an LED volume with LED roof and floor?
Well, yeah, there's quite a few options for where you can place the tracking markers, these little stickers. You can invert the star tracker and put them on the floor if the floor's available to you. It might not be, it might be set, but if it's available, that's one option. You can tilt the star tracker back. It doesn't have to be pointing directly up. So normally LED volumes will have ceiling over part of the volume, but there's normally, normal studio ceiling or fourth wall that's not, that is available to put tracking markers on. So that's another option. But what we've been doing more recently, and in fact, Marcus, you just came back yesterday, didn't you, from a set where,
yeah.
Sorry, that's not very good, is it, my phone? Yeah, you came back from a set yesterday where I think they used a net, well, you used a net, because I think you put it up, didn't you? Do you want to talk about it a little bit?
Yeah, so when we go to trade shows for like a not permanent setup, we often use a net where we put the stickers on a net and then we put it really tight. And we use the same method to drape it over the LED walls. So you would still get the light from the LED walls, but you would also have the reflective markers. Like you can still track of them. So that was the solution they worked with, and it worked very well.
Great. I suppose just to add one thing to that, that once you've got your stars up, then you can add multiple cameras to the volume as well. So one of the things that's quite cool with LED wall is you can cross shoot two cameras. So you can have a kind of wide mid type camera, and then you can have a camera on a longer lens picking up a profile close up or something like that. And you can actually have two frustrums running in the same LED wall space. So one that's covering your wide over there and one that's covering your long shot over there. So the and because the tracking system is absolute, those cameras know exactly where they are in absolute terms. You don't have to like calibrate anything. You just set them up and go, and you can add more and more cameras.
Okay. So I don't see any more questions. If you guys have more questions, now is the time to ask. Oh, there's one. What will be the spec of LED used for the test?
Do you mean the LED wall we have in our volume? What spec is that? Maybe perhaps
yes,
that's what they're asking. So I think the one that you just saw in our studio there, that is a 2.1 mil pitch. 2.5 mil pitch LED from CT London. The higher the pitch, sorry, the smaller I should say the pitch, the more expensive the LED wall, but also the easier it is to get rid of the moire effect by pulling, setting a depth of field.
Mm-hmm. And a follow-up question, how many cameras can we use at a time while shooting?
So in a previs environment, so I'm guessing you mean in a sort of previs VFX environment, you can use as many cameras as you want. You just have a previs engine for each camera. So when Mike was talking about camera chains, that's what he meant. So if you have 4 cameras on set, then you have 4 camera chains. So you have an engine for each camera generating the previs for that. But then for live production for the corporate market, we also have this Star Tracker Studio, which allows you to have more cameras with only 2 engines and 1 keyer. So that's a kind of cost-effective way of adding more cameras. But in a previs environment where you want those cameras to all be running at the same time, and they're all going to be recording at the same time, then you'll need an engine per camera and a VP Pro per camera.
Mm-hmm. One question regarding lens profiles. Do we get pre-calibrated profiles, or it's done requirement basis? What's the turnaround time on shoot day?
Yeah, so we have a kind of 2-stage process to calibrating the lenses. We have a high-end specialist process that we do here in our lab, and from that we create a base file for the lens, and we're building up a library of these now as we speak. Someone is calibrating a huge Optimo zoom that's about this big on our camera calibration system. Now, but once we have that base file, you can then take that same file and find, if you have a similar lens, you can use it as a base file and do a tweak. And we call this the tweak. It's a piece of software you get from us, the Lens Tweaker. And that allows you to tweak in your own lens. You don't need specialist equipment. You just need a couple of lighting stands, and it's kind of a process that you can go through on set. Takes between 10 and 20 minutes per prime lens, maybe about 30, 40 minutes, maybe up to an hour, depending on the quality of the zoom lens. So it's something that you can do on set on the setup day, and that's what we recommend, because no lens camera combination is the same. The distortion is going to be different when you take the same lens and put it even on the same model camera. So I've got an Arri Alexa over here and another Arri Alexa here. If I take the lens off and put it on this Alexa, the distortion will be slightly different. So we recommend tweaking in the lens to get the best possible join up between real and virtual. Yeah.
And this includes cine lenses and anamorphic lenses?
Yeah, that's right. Yeah, so we can, it's not just zoom lenses, we can do cine prime lenses, and anamorphics is something we've just started to work on. We did an anamorphic lens just earlier this week, and there is a lot of complex distortion, as you might imagine, in an anamorphic lens. So we're working on a model for that, but our temporary approach is that we treat it as a spherical lens, de-squeezed, and that gives reasonable results. But we are working on improving that to get a full mathematical anamorphic model.
Okay, question from Paul. Does the current plugin support curved LED walls?
Absolutely, yeah. You can have any mesh of LED wall that you want. It can be an S shape if you want. It can be a curve. It can be like our one, which is 3 straight walls. Those straight walls don't have to be perpendicular. So you can have any arrangement of screens that, that suits your production. And then you use the end display system in conjunction with our plugin to sort of help with the configuration of it. Oh, I should say, with a flat screen, we've got a cool little feature where you can, so not with curved screens, this doesn't work, but with flat screens, you can actually take the star tracker and use it to create the LED wall mesh, which is quite a neat thing. You just walk it around to where the corners of the real one are, and it will create a virtual copy of that in the scene.
Okay. Yeah. Are there any more questions? Oh, question from Alex. Do you have gesture control interactive touch for big curved wall?
Wow, no, that would be really cool though. No, we don't really do any sort of hand tracking or anything. When we do motion capture, we use XSEN suits. I think they're brilliant. They're, recommend checking them out. XSENS. They are inertial suits, so you don't have to have a lot of installation. It's just something you put on, and the calibration process is quite quick. And then for hand tracking, we've been using something called Manus VR in collaboration with the XSEN suit. And then for VR, we've been using Leap Motion. All these things are all these different tracking systems, or at least most of them, will have a plugin for Unreal. So you can bring them in and then attach them to things that you're doing in Unreal. But hand tracking isn't something we do at the moment.
Mm-hmm. Question from Mikkel. Maybe this one is for Mike. How many computers does one VP Pro license include in case of main and backup computer or multi-camera production?
Right, so VP Pro license normally is 1 per computer, except in Star Tracker Studio where it's VP Studio, which is either 1 to 8 or 9 to 16 capable camera chains. But for doing film virtual production workflows, it's 1 per computer. So in a backup environment, you would need 2 VP Pro licenses, even if you weren't using the second one. James, I'm not sure there's a smart way around that, is there? I think it's just 2 straight licenses you need.
No, I mean, yeah, no, not really. It's locked to a machine. It's node locked to the license. Yeah.
Yeah. It's relatively cost effective per PC. So, if you're doing the right size budget film shoot, it shouldn't be a problem, particularly if you're renting from a company. They're not expensive.
Okay, thank you. Yeah, it looks like we reached the end of our questions. If there aren't any more, I'm just gonna wait a bit. I think we can wrap it up.
Great. Well, if anyone does think of any other questions, feel free to contact us. And also, if you already have our hardware, if you've already got a Star Tracker or any of our robotics or hardware and you want to get it hooked into Unreal. You can of course get the free plugin right now, download that from the marketplace, and we can also provide you with a trial for the Pro plugin. It's not much use if you don't have the hardware, so but if you do and you want to just try out Unreal for your production, then please get in touch with sales@mo-sys.com. Also, in terms of LED wall, there's obviously a lot of interest and a lot of tests going on at the moment. I think we may even end up doing a webinar specifically on LED wall. You know, do please contact us. We will, if you have a project, we can advise and we can help out, and we can you know, offer that as a service to the production too.
Okay. Yeah, there aren't any more questions. So I think, yeah, we can wrap it up. There was one question earlier asking if there's going to be a recording of this webinar. And yes, there will be. We're going to put it live beginning of next week on our website. We're also going to send around a newsletter for everyone who signed up. But yeah, for now, thank you, Mike. Thank you, James.
Welcome.
Yeah.
And thanks to everyone watching, and see you next time. Bye.
Bye.